All right, I think we should get started. Richard, do you want to kick us off?
Yeah, sure. Let me first set my screen so that we have visibility. All right. So Robin and I are going to be presenting this webinar on best practices for Ray in production. Um, we're in the same room, so my voice will go through Robin's camera, but you can just follow me as part of the slides. So just to kick things off, I'm a product manager here at AnyScale and one of the co-authors of the Ray project. Previously, I was one of the PhD students that worked on Ray at UC Berkeley. Robin, do you want to quickly introduce yourself?
Hey, folks, my name is Robin, and I'm part of the technical staff here at Ainscale.
Cool. All right. So today we'll be covering a couple of sort of topics on the agenda. We'll start with what Ray is and what it's good for, very, very light. This is mainly to orient ourselves here. And if you were sort of new to Ray, we do recommend you going through some of the other sort of materials that's on the Ray website and the Ray documentation. We'll then go into a couple sort of reference architecture examples of how people are using Ray in production. And then we'll cover what are some best practices for deploying Ray in practice. And then finally, we'll sort of conclude with sort of how AnyScale is positioned to solve some of the problems and sort of production considerations when deploying Ray for a large organization. So Ray basically consists of two main layers. There's a higher level layer, which provides libraries for enabling simple scaling of AI workloads, and a lower level distributed computing framework, which is what we call Ray Core, that has a Python first API and is also suitable for scaling very numerical and GPU intensive computation as well. In particular, when we look at Ray, one of the primary sort of ways we position Ray is to target sort of core components of the machine learning workloads. And in particular, we think we care about these higher level libraries, which allow you to scale the sort of computationally intensive parts of the machine learning workload. So this includes data preprocessing, training, tuning, and model serving. And there's sort of representative libraries that capture each one of these, Ray data for data processing, Ray train, and Ray tune, Ray serve, so on and so forth. Finally, there's also all these sort of libraries are built with key integrations with the ecosystem in mind. We're sort of very well aware that the machine learning ecosystem is very fragmented and very sort of organic. And so we sort of design these libraries to be very compatible with these other libraries and other systems from day one. So that's kind of the broader picture of like where Ray fits and how it fits into the broader ecosystem. So again, if you're sort of new to Ray, we do recommend you going to the Ray documentation and the Ray website to learn more. I'm going to the rest of this talk will be sort of oriented towards people who are trying to think about how to put Ray into production and what are some reference examples and architectures they can learn from. So I'm going to walk through 3 examples of these Ray in production architectures. First one's going to be from Pinterest, second one's from Samsara, and the third one's from Spotify. So Ray at Pinterest is sort of designed where in a way such that like becomes a compute core for all the machine learning workloads. And this will sit in the midst of a variety of different components that in composition create a machine learning platform for the rest of Pinterest to use. So as you can see from this diagram, Ray here sits on top of Kubernetes, connects with S3, MLflow, and their internal sort of metrics collection mechanism, and then also is exposed to the user through a variety of different Pinterest-specific tooling or UIs or sort of application interfaces. You can also note that the key workloads that Ray sort of supports within this diagram are listed as batch inference, training, serving, and fine-tuning. This is something that we see very common across different users as well. And then the sort of key components that we have here, I would like to call out 4 in particular. One is MLflow for model tracking. Jupyter notebooks for interactive development and interactive usage of Ray, Airflow for workflow orchestration, and then Kubernetes for cluster management. You can find more information about how Pinterest went through the journey of deploying Ray at this blog link I have below in the slide. Next, we'll talk a little bit about Samsara. Samsara, in their blog, they don't provide a block diagram necessarily, but this is a sort of a workflow sort of perspective. And what they sort of think about is how Ray fits into the core user journeys of a machine learning developer or machine learning practitioner within Samsara. And so you can see that like the journey is sort of categorized into stages, but really you're going from an idea or ideation, and then you're collecting data, you're creating the model, and then you're evaluating, deploying it, and then you're maintaining it over time. And so of these 7 different stages that they have here, they really think about the workloads as characterized as a subsection of these segments. And so as you can see here in blue, they have a data processing section, a training and batch inference section, an online inference section, and then like a retuning section or monitoring processing data section, which is kind of like closing the loop. Well, in particular, I think one thing that I would call out that here is similar to what we see in the Pinterest sort of use case. There is a couple key workloads that are being used or where Ray is being used for data processing, training, batch inference, online inference, and also hyperparameter tuning. I would also call out here that like the key components are there are many similar components, but there's also some key differences. They do use an orchestration tool such as Daxter, and they do use Jupyter notebooks. But one thing that is also sort of special in Samsara's case is that they also leverage Spark on Ray very heavily. In particular, this is important from a machine learning platform perspective because this allows them to sort of unify the entire sort of workflow from data collection into training and deployment. And this will reduce their sort of platform overhead instead of needing to maintain 2 separate cluster deployment sort of monitoring stacks and so on and so forth, one for Spark, one for Ray. Obviously, this is a design decision that they chose to make, and it's not that we see this across all of the different companies, but it's something notable to point out. And finally, we can talk a little bit about Spotify, and this is sort of an early diagram from 2 years ago, where when they started deploying Ray within the production environment or within the machine learning platform. And the primary angle for Spotify originally was so that they could sort of expand the usage of their machine learning platform beyond TensorFlow. And so as you can note here, like Ray sort of unlocks a large ecosystem for them. They have like now the ability to go beyond TFX and are able to use things like PyTorch and XGBoost and Hugging Face on the same sort of training platform. And there's a lot of sort of ecosystem integration, both from the machine learning side, but also internally. The key workloads that they care about, which perhaps is not listed on this particular diagram, is like training, batch inference, and hyperparameter tuning. And the key components, I would say, which are sort of listed in the blog below, also include Ray plus VS Code, and then they leverage Flight for orchestration, and they use they connect to in-house services for monitoring experiment tracking. So we've sort of looked at these 3 different deployment architecture, and I kind of want to draw a couple key takeaways from here. The first is that like there is a sort of common sentiment on how to deploy Ray properly, and that is to use Ray for key machine learning tasks. Obviously, there are people who use it for scaling Python and ad hoc data processing as well, but first and foremost, across these machine learning platforms, we are seeing Ray sort of become the compute core for leveraging these for being leveraged for these key distributed machine learning tasks and training with all the different machine learning frameworks in the ecosystem. The second sort of takeaway I would have here is that like there is a lot of work that they do to surround Ray with key components to complete these machine learning workflows. There's a lot of key complementary systems, in particular around workflow orchestration, which allows you to do to sort of chain these like big Ray jobs together, and then also cluster manager, which typically tends to be Kubernetes. There's also quite a bit of work that they do on tooling and exposing the Ray cluster properly. So they do leverage Jupyter and VS Code very frequently. And then there's obviously like observability and model tracking work that they do as well, in which MLflow and weights and biases is very common as well. But MLflow and other cloud services are what are being presented in the diagrams above. So now that we've sort of covered like the broad sort of scheme of different reference architectures, I kind of want to zoom in a little bit more specifically on specific deployment best practices for Ray. And I'm in particular, I hope this will be very useful because of the many people who are on the call today, I think there's going to be a variety of different sort of experiences, and where we're sort of aiming towards is towards people who are a little bit more early in their deployment journey. So people are familiar with Ray and a little bit earlier in the deployment journey in sort of figuring out how and where to put Ray properly. And hopefully these best practices will sort of help sort of accelerate that journey for you. And so I have sort of three baskets of production best deployment best practices. And the three baskets here are production readiness, the developer experience, and observability. And each one of them, I'll have a couple tips and sort of walk you through them. And so let's start first with production readiness. With we sort of often see a question around production readiness, which is a very simple one, which is simply like, how should I run multiple jobs? And should I run multiple jobs on the same Ray cluster at the same time? Now, I think to first and foremost start, it's best practice to run one job at a time on a single Ray cluster. I will say that it's quite common to have a single Ray cluster and then run multiple jobs in sequence on it, but typically we try to avoid recommending running simultaneous multiple tenants or multiple jobs on the same Ray cluster at this time. The reason is because Ray currently doesn't have the physical resource isolation sharing or isolation between jobs. And this can lead to noisy neighbor effects where one Ray job can interfere with the performance or like the stability of another. Ray also doesn't have sort of the standard multi-tenancy support features, including like fairness, prioritization, sharing between independent jobs, and also again isolation. And therefore, like it becomes very sort of tricky to be able to run multiple Ray jobs at the same time. And instead, we do recommend using like another cluster manager to sort of manage these like smaller clusters, these smaller Ray jobs, and instead use something like Kubernetes or Anyscale. Now, another sort of very common deployment production readiness best practice I get that is like, how do I use Ray client to run my applications? Unfortunately, right now we're sort of not really maintaining Ray client, and there's sort of like we need to sort of figure out exactly how we extend this forward. And so I think a best practice here is to avoid using Ray client as much as possible. And there are situations where perhaps Ray client can work, but it's not really the golden path. And so if you're thinking about designing your sort of platform, I would sort of recommend designing against something that's a little bit more standard. For example, like being able to leverage the head node properly. Ray client also doesn't work really well with some of the architectures of the Ray libraries, and therefore we sort of need to like it sort of produces a bit of impedance mismatch for your platform. We do suggest most commonly just like making sure that the head node is exposed to the user and they can sort of run jobs as if they were running on the VM. So this is sort of some of the production readiness comments, and we do sort of are open to if you have any questions, feel free to leave them in the chat, and we'll sort of answer them at the end of the call. So we're gonna go ahead and move on to the second basket, which is around developer experience best practices. And the question that we also often get, which is kind of related to the previous point about head nodes, is like how do we avoid OOMs at scale or out of memory errors or sort of memory stability errors at scale? And one of the things that we do recommend, especially on Anyscale, where we offer a production ready Ray platform, is we do try to avoid at large scale, avoid sort of doing task scheduling on the head node. Now, that's a little bit different from sort of when you're smaller scale and you're sort of iterating more quickly. It's actually much more convenient to sort of be able to sort of test things out on the head node. But at large scale, like tens of nodes, sort of, or like, hundreds of nodes sort of situation, like a lot of the sort of production workloads can get really long and very expensive. And having the head node sort of be in a sort of in a state where it can get owned by applications or like the application logic can be sort of troubling. So again, like the head node is a single point of failure, and we do recommend avoiding overly relying on the head node, so designing applications to use, for example, cloud storage instead of like a local head node file system. And then in order to sort of do this in practice, you just basically set the number of CPUs on the head node to 0. And this will allow the head node to sort of be more clean and avoid like spilling issues or out of disk, out of memory issues that may occur because the application has some logic and some tasks that are placed on the head node. So the other thing is that we do recommend setting up VS Code for Ray as the best developer experience, especially like if you're on the head node, you want to have the ability to program against Ray in a very flexible way. And so again, the reason for this is Ray can be used in both interactive and non-interactive environments. And VS Code provides sort of the ability to do that in the same tool. And then also there is a Ray distributed debugger, which offers a VS Code front end, and that would integrate very well. Of course, we know that like there's other sort of tools that people use, whether it's like PyCharm or Cursor, and for the most part, any sort of VS Code fork with like Cursor would sort of have similar properties. We are sort of investing in figuring, we're looking at internally on the Ray team at Anyscale how we can better support like a PyCharm experience as well. And finally, we'll talk a little bit about observability best practices. The first thing is to leverage the Ray dashboard for performance insights. In particular, the Ray dashboard is oftentimes like an overlooked tool, I feel like. It does provide great insight into job performance and bottlenecks, has like in-depth views for a lot of like Ray core specific things, task actors, and the underlying hardware. For example, it allows you to easily analyze like CPU and GPU utilization and performance for these individual tasks and actors. And I think that's actually quite valuable for a lot of applications, especially when they're looking at performance issues. And finally, if you haven't already, this is pretty standard in production, but definitely recommend using Grafana and Prometheus to get the application level observability. We do offer observability integration with Prometheus for this metrics collection, and this is a sort of very well-documented part of the Ray documentation. If you run into any issues, obviously, please raise it as a GitHub issue. We do sort of also allow you to capture custom metrics using the RayUtil metrics package. And this allows your production, your Prometheus and Grafana sort of visualization to be a lot more robust and much more application, capture all the semantics that only you would know. So, so just to recap, we talked a lot about like production readiness, providing an integrated developer experience and observability, and all this what we can do on Ray and how to do all this on Ray. But there's also sort of other aspects of deploying in production that might be sort of considerations for a lot of teams, including how do you sort of improve governance and sort of administrative capabilities. How do you manage your cluster effectively and reduce costs? And how do you sort of optimize the performance of your Ray applications? And so I'm going to hand it over to Robin, who's going to talk a little bit about Anyscale and show how Anyscale sort of provides a way to capture or to sort of move forward with these applications at a way that is going to accelerate your Ray deployment and adoption. Robin.
Awesome. So as we dive a little bit deeper on exactly, what would be needed as you move to production, one thing that I would like to call out is that diving deep into production readiness, you would likely require the ability to be able to essentially create a queue out of all the jobs that you have so that you don't have to start a cluster every single time a new job is launched. In a little bit, I am going to talk about how Anyscale makes it super easy for you to be able to, launch the clusters quite ephemerally and they scale up quite fast. But essentially, for jobs that might be running for less than a minute, you don't want to restart the cluster, and for that, you need a job queue, which you can basically define with different policies: first and first out, last and first out, and execute that against a Ray cluster. Second would be multi-cloud support. This is one of the big reasons why we have seen adoption of Ray, where folks would want to be able to use the same exact, compute substrate across different cloud providers, where they might be getting, more cost-effective GPUs. So it's something that you would likely want to build out in order to make sure that your organization can truly serve, very cost-effective accelerator across the board. Some other users also tend to use the ability to have Ray on-prem to be able to manage the cost effectiveness. And we have seen patterns where users can define, a job which can go from running on an on-prem cluster to the cloud cluster in case there are not enough resources available within the on-prem environment. One of the most important feature that you would definitely want to use in your Ray cluster is workspaces. Workspaces is essentially, having the ability to have some sort of a VS Code and IDE running directly onto your Ray cluster. So you can basically minimize the time it takes for you to go from development to production. So that's something that it would highly recommend that you have some sort of a VS Code running or your preferred IDE running in the head node so you can go from dev to prod seamlessly. If you are running production services, you would want to make sure that your services are highly available. And this is something that you can accomplish with open source by setting up like the GCS with Redis. But this is something that will be required as you start productionizing your Ray cluster. And job retries. So for example, if you run a job and for some reason it fails, you want the ability to be able to rerun the job multiple times before the cluster gives up and says, hey, it's done. We're not able to run this. A lot of these functionality is already available within the Anyscale platform, and we can go a little bit deeper, on how it exists. But essentially, based on our learnings from production environments of using Ray in production, we have learned a lot of these lessons and built that into the Anyscale platform. Second, diving slightly deeper into governance. Once you start moving things into production, your team would require effective governance to be able to make sure that you're following the right security policies. So making sure that your Ray clusters are behind some sort of like a single sign-on, having the ability to be able to manage compute quota is going to be critical as well. So one of the things that we see is that once you start running Ray clusters in your organization and you're using large number of GPUs and obviously Ray supports other accelerators like TPUs and like some of the new accelerators like Inferentia and Trainium from AWS, you would want to make sure that your team has effective controls over which team can have how much amount of resources so that you don't have some sort of runaway cost runs. So making sure that you have effective quota management is quite important. Once you have quota management, you also want to make sure that those exact teams are utilizing the hardware cost effectively. Like they're actually using and they're not like idle systems or Ray clusters running behind the scenes. So usage tracking is something that you'll likely have to build out where you would essentially export all the metrics from the running Ray clusters into some sort of a unified place, and you want to see all those metrics to make sure across my organization how many clusters are running, what's their utilization. You'd want to make sure that your data, both at rest and in flight, stays encrypted, and you want to export all the logs from your jobs and services to make sure that in case you have to go back for auditing purposes or have to do any retrospective, you're able to have effective logs through which you can search. Again, a lot of these lessons have been learned over the years, working with companies to move Ray Ray applications into production, and it's been baked into the Anyscale product. The third and the most important pillar, personally, I find is the ability to observe and monitor my applications. The first time I basically run my Ray application, immediately I want to start optimizing it. And I want to optimize it to make sure my Ray application can run even faster than before and maximize the utilization perhaps of my underlying hardware. One of the most important things that you would want to make sure is that once you fire up a Ray cluster to run a job or a service and it shuts down, you do want to preserve the logs that were generated from your application. Sometimes I've seen, like personally, going back to even 30 days, having the ability to be able to search through logs just saves me quite a bit of compute so that I don't have to rerun those jobs again and again. You would want to make sure that all these logs can be perhaps exported into the platform of choice. Maybe internally you use Datadog and CloudWatch. And for those places, you would want to make sure that all these logs can be exported and viewed in a single place. You also want alerts in case your job fails or in case your service has any disruptions. At midnight, you'd want it to be able to alert it by your Anyscale, by your platform to make sure that it's something that's able to support you in production. And one of the things that we hear quite often is the fact that like when you're running a large Ray cluster, which has a large number of worker nodes, sometimes it gets quite difficult to make sure that these logs across all the worker nodes can be collected and you can sift through them effectively to debug your application. You'd want to build out some sort of a unified log viewer on top of where we're running, Ray, maybe that's VM based or Kubernetes based to make sure that you are able to debug those applications effectively. Tracing is going to be also important when you're running, when you're either profiling your CPUs, or you're basically, trying to profile your services for latency purposes, and making sure that when you do eventually run into any issues or bugs, you're able to resolve these bugs effectively with some sort of a distributed debugger. Again, a lot of this functionality is already baked into the Anyscale platform, and we make it extremely easy to be able to essentially take your jobs, so take your applications to production, and then to debug them, if needed. So just to kind of zoom out, this is a good representation of how this ecosystem looks like, where Anyscale, at the core of it, make sure that we are providing you all those secondary features that's needed to be able to make sure that you remain as productive as possible developing these Ray applications. But at the heart of it, we essentially have our own proprietary version of Ray called RayTurbo. This proprietary version of Ray makes it possible for you to be able to scale to any scale, no pun intended. It makes sure that you can basically really optimize your application, and these applications would run better, have fewer ooms as compared to running these Ray applications with an open source Ray framework. You also have, with all the features that we have built around the Anyscale platform, the ability to be able to run compute any way you want, and I'm going to go deeper into that. You have the ability to be able to use any hardware accelerator that you possibly want. And all of this is provided with the same exact interface. And we have built out quite a bit of integrations as well to make sure that as the world is evolving from classic machine learning models to bigger and beefier models, we are able to support you through the journey to make sure that you can use SGL or VLLM or TensorRT LLM, in case you want to experiment with different inference engines. So just to summarize, Anyscale essentially provides you the ability with all the lessons that we have learned to make sure that your jobs and services are production ready, so that you're spending less and less time on making sure that these services and jobs are running properly and more time on taking your models, taking your applications to market and making sure that they can scale effectively. We have a very smooth developer experience where you can onboard and get started quite seamlessly, and your Ray journey becomes much smoother. We will make sure that, with our enhanced observability, you're able to debug the applications much faster, and you don't have to build a lot of the sort of the supporting features to make sure that you can, debug things effectively. And for the administration teams, we give them effective controls on the infrastructure to make sure they can see exactly what kind of compute is being utilized across the organization, and they can provide specific quotas and a reservation across teams to make sure that only the performance, only the hardware that's required per team is allocated. And based on the work that we've done with RayTurbo, which I'm going to dive into just a little bit, we're able to give you performance that's optimized so that you can run your applications much faster as compared to open source RayTurbo, open source Ray. So just diving a little bit deeper onto some of the value that Anyscale platform brings and how it makes the journey of developing Ray application much more seamless. Since we mentioned earlier, workspace basically is a function with which we provide your best, your preferred IDE running on top of the Ray cluster. With that, you essentially have the same exact interface that you had previously that you're used to, be it using VS Code or Jupyter Lab or using Cursor. And basically, with that, you can essentially log into the head node, write your Ray application, start developing the Ray application interactively, where worker nodes could be scaled up and down, as your application requires it. And once you're ready, you can basically just use a simple CLI to be able to take that to production. This experience is really seamless, and it really makes sure that you're not spending time on just dependency hell, making sure that your dev dependency and production dependencies are same, and it's performant. We've also built out a distributed debugger to make sure that any issues that happens with your application can be quite easily debugged. And then we have the integrations built out so that if whether you're using weights and biases to track your experimentations or using MLflow to be able to do that, we have quite seamless documentation and like integrations built out to make sure that you're able to quickly integrate with your preferred applications. Something I mentioned early on, which is Ray is something that you can run anywhere, and this is one of the superpower of Ray. So, with any scale, we have taken that a step further, where we have deployed a control plane and data plane architecture. What that basically means is, control plane is running into our cloud, and data plane runs into your cloud, wherever you're running your compute. And the only thing that we exchange between these two surfaces is the ability to be able to make sure that we can orchestrate the right machines and fire up the right clusters. So your data plane can be running wherever you're running compute. It could be running on AWS or GCP, or if you choose, it can be running in your on-prem data center. And in fact, if you really want, you can actually run this, on a machine that's sitting under your desk. So going from a machine that's under your desk to all the way to cloud, you can have the same exact user experience, and you can move quite rapidly across the stack. We can also run any scale, whatever you can run Kubernetes cluster. So be it AKS, GKE, AKS, or anywhere else, third-party cloud provider where you might be running a Kubernetes solution. Diving deeper into the observability on any scale, this is one of the most important feature, at least for me personally, because I've had my own shares of struggle, debugging and optimizing my reapplication with the open source cluster. So we have built out tooling to make sure that it's super fast for us to be able to aggregate metrics that's being generated with all these Ray worker nodes, and they get streamed into a single pane of glass. So with a unified log viewer, which you can see on this particular slide, right next to metrics, you can essentially click through that and search through all the logs that's being generated across all the worker nodes. And it gives you a very interactive, seamless experience to debug any one of your applications. You can set alerts for your application based on some of the metrics that you're seeing here. And you can also essentially you get access to a Grafana dashboard, a managed Grafana dashboard, where you can essentially configure exactly what metrics you might want to see within your application. We're in the process of rolling out enhanced dashboard for specific applications. So for example, if you're developing a Ray data application, train application, or serve application, we are actively rolling out specific dashboards so that these specific applications could be debugged much faster. And again, as I mentioned before, we do have integration with Datadog and CloudWatch. This is one of the features that that gets admired by the admins of infrastructure. With this single pane of glass, right at your home screen, you have access to the computer running across your organization. So you know exactly within my organization and within the project, which team is using exactly how many machines and what is their current utilization. This gives you a very quick snapshot of exactly what's happening behind the scenes, so that if in case there are some unused hardware behind the scenes, you are able to go and debug that quite effectively. I mentioned the ability to be able to have the worker nodes being added very fast. And this is something that we actually spend a lot of time on. So with AnyScale's cluster manager, we've made it super easy for you to be able to launch a cluster, and it happens really fast. In fact, if we were to ever show you an interactive demonstration, essentially I can fire up a Ray cluster from cold start to completely up and running in less than 60 seconds. This thing is like really amazing, especially when I want to be able to go and experiment with different configuration and different environments. I'm able to start a cluster from cold, in less than 60 seconds with all my dependency installed. Gives me the ability to be able to move these jobs into into a different Ray cluster, knowing that those worker nodes and the head node will be started very very fast. So this is the work that we have done so far, and we are making it faster and faster. We are investing quite a bit of energy to make sure that the startup time remains at the cutting edge. And in fact, there are times when I've actually launched, 10, like 1,000 clusters or 2,000 clusters, and it again takes 60 seconds because it's all parallelized and it executes extremely fast. We do have the ability to scale down to zero. Again, having the power of an ephemeral cluster, we can essentially shut down or scale down the cluster depending on the traffic, depending on the needs, and it happens quite aggressively as well. And then we do have one of the most important features, which is in case you're developing an application and you want to utilize spot instances, because let's say 8 GPUs are much cheaper when you try to use that on a spot instance. With a single flip of this UI that you're seeing out here, you are able to switch over from using like an on-demand A10 machine to a spot-based 810 machine. So that seamless experience without having to change your application code gives you quite a bit of power and cost efficiency. So with this particular UI, with a single flip of a button, I can start using spot-based instances for my application without having to change anything in my application code. And by the way, everything that you're seeing on the UI can also be configured and some more with the help of our SDK and CLI that we have built out around any scale. And finally, RayTurbo. This is the proprietary version of Ray that runs within any scale, and that's only available at any scale. And this allows you to be able to get more out of your machines that you're currently running. So that includes some of the proprietary features like elastic training. We have done optimization within RayServe to make sure that the QPS it can serve is really astounding. It's able to have zero downtime when doing incremental rollouts, saving you quite a bit of cost, especially with expensive A100 based, let's say, hardware. And we have done quite a bit of optimization with Ray data itself, so that aggregations can happen much more effectively, and you're able to run operations that you previously couldn't with Ray. This is a really big area of investment within any scale, and we're trying to make this even faster. Especially if you have had issues in the past around OOMs. This is something that we have really solving much faster with RayTurbo, and also the ability to scale up. The ability to scale up with RayTurbo goes much beyond what you can achieve with an open source Ray cluster. So just to summarize, essentially, with any scale, with RayTurbo at heart, we have built out these necessary features that's required to make sure that you can go from dev to production much, much faster, and you can monitor the usage that's happening of your compute across the organization. With that, you are able to still leverage the power of the heterogeneous power of Ray framework, and you have the ability to keep using your preferred frameworks alongside Ray. So would you like to recap for us, Richard?
Yeah, I'm happy to. So to recap, we just talked about what Ray is. We also sort of walked through the reference architectures for a couple key companies like Pinterest, Samsara, Spotify, and how they deploy Ray in production. We answered some common questions about using Ray in production and provided best practices there. And Robin sort of gave us a deep dive on how any scale improves Ray production readiness, performance, observability, in addition to governance, compute management, and developer experience as well. And so this concludes the main part of our talk, and we're going to sort of now head into the Q&A section, within which we see, we have 38 open questions. So we're going to sort of go through this one by one, and I'll take the lead here, and
Sure.
I'll tag you in, Robin, as we go. So presentation slides are unreadable. There's a variety of, it seems like there's quite a few of these like presentation questions. We will be sending out there'll be, this is a recorded session, and I believe we'll be sending out like a PDF of the slides later as well. And so yeah, stay tuned for that. We'll definitely get that out to you. Um, Manuel is interested in building a partnership with Anyscale for their private AI enterprise offering. How should Manuel take that?
Fantastic question, Manuel. Thanks for your interest. Essentially, just email me at robin@anyscale.com, and then we'll be able to take the conversation forward.
Great. How is Ray used in LM pre-training, and is that going to be covered in this webinar? That's not going to be, unfortunately, it's not covered in this webinar, and we'd be happy to sort of do a follow-up session there. Basically, at scale, like Ray provides a lot of performance benefits, and in particular, especially the cost optimization, because it allows you to have much better control over the fault tolerance. There's a lot of papers that sort of talk about this. For example, you can refer to the Pathways paper from Google, and that sort of talks a little bit about where Ray's benefits at scale come from. Yeah, so we're not going to talk too much about this, but hopefully that gives you some pointers. Does Ray leverage NVIDIA GPUs for machine learning training and inference? Yes, it does. Ray sort of has first-class support for GPU awareness and scheduling and location. And so it does a lot of stuff, including like manage the CUDA visible devices, sort of allows you to do scheduling, and sort of allows you to you can also leverage nickel out of band. And also another big part of what we're working on in the future is around compiled graphs and GPU objects. So then you can keep objects within the HBM and transfer them across different actors or tasks very effectively. Young asks, what is considered a job? And sorry, I didn't define this. Usually this is considered as like the full lifetime of a Ray driver script. So you have an application that runs and it connects to the Ray cluster and concludes. And typically that is counted as like a Ray job. And it's also shown on the dashboard. You can see like as soon as like the program exits with a exit code, then that will get tracked as like a completed job on the dashboard. Is it possible to train multi-agent reinforcement learning using Ray clusters? And the answer is yes. We have thorough documentation on the Ray docs about this. Multi-agent is something that you would be able to do with RLib, and there's like first-class support for that. Brandon asks, since you recommend running one job per cluster, do you find that is common to ephemerally spin up clusters in demand, depending on job load? Yes, that's very, very frequent. In fact, like, for example, when I use Ray, like I will sort of spin up various number of clusters depending on what experiments I'm running and so on and so forth. And it also just depends on how much I want going on at the same time. If I'm like actively working on a project, I'll just have like one cluster running and I'll just submit jobs to that over time as I sort of update and improve my program. What's the options to avoid Ray client? Typically what you want to do is you instead want to just run Ray on the head node of cluster and then have it connect, have the driver script connect to that via ray.init. And usually ray.init, like you usually don't need to even pass in anything. The Ray, like, it will automatically detect that you're on the head node and connect, and you are able to scale out your application. Can you speak about, Brandon asks, can you speak more about avoiding OOMs and why it's necessary? Head node should have its global control store process backed by Redis, and worker OOMs should just be checkpointable and resumable. So what will happen is that, for example, like Ray allows you to schedule tasks on the head node and the worker nodes. And so, for example, if you have a worker, so basically then, like, let's say you're doing a data processing task, that means data processing tasks individually will be both scheduled on the head node and the worker nodes. And so if you have data processing tasks that's downloading a lot of data and perhaps like doing a lot of memory sort of high memory pressure activities, it may be possible to like completely kill the head node because you OOM the head node, and that also sort of wrecks the Redis process or whatever GCS process that you have for managing metadata, and the entire cluster collapse. Hopefully that provides a little bit more detail. Sukumar asks, we are hosting machine learning models using RayServe in KubeRay. Very nice. We created multiple replicas and we specified spread. Is it possible to spread these replicas across availability zones instead of, and is it possible to do strict spread? I believe so right now I don't think I have the answer to this question, but I would recommend you posting on the Ray Slack on the serve channel in order to get sort of a better answer there. Existing OTel integration.
Yeah, this is something that we have both in open source and with the N-Scale platform. So let me just link you the documentation. We have like a pretty good support for tracing.
In RayServe on Kubernetes, Saide, sorry if I pronounced it incorrectly. Saide asks, okay, on Kubernetes, the working dir is often used to fetch code for deployments, for best practices for managing and using working dir. So the best practice here is like make sure that like either I mean, practically speaking, you should probably just make sure the code is available on your Docker image. That's like the best like very industry standard practice. Now, I think working dir allows like a little bit more flexibility there, which is like if you're sort of iterating and you're doing stuff like may not necessarily like require a Docker image to be baked yet. Like you do sort of want to have the ability to iterate very quickly. Hopefully that provides more context. Guillermo asks, does Ray support other AI chips, including TPU and Maya? So Maya, I believe we do not support yet, but TPUs are definitely being supported, and we're working actually very closely with the TPU team to support that. And we also have support for, as you mentioned, Tritium, and then there's also some work on AMD chips as well.
And for TPUs, I mean, we have folks using TPUs in production at a very large scale with N-Scale.
Yeah, and the other thing is, I think also like the HPU and the Intel chips as well are also being supported. Hopefully that provides a good answer. Collecting traces of requests when.
Yep, same. Let me just I'm posting the link to the to being able to do this with the N-Scale platform, and there is available like it's available with the RayServe as well. So if you go to the Ray docs, you should be able to find this.
Pro corrects me and says I should be using OpenTelemetry instead of how I'm. Yeah. Okay. Thank you. Got it. All right. Yes. Kirill asks whether the Ray Prometheus integration is done using Vector. That is a Vector is provided as an integration as well. Jacob asks CPU and GPU usage metrics on the dashboard are updated every 5 seconds. Are the value displayed only a short-term snapshot every so I believe the dashboard should be able to show you a time series as well. And I believe like it's not an average over I believe like I mean it depends on how you I don't think you can actually check what SMI command is being run in order to calculate the GPU metric, but it should not be like yeah, I actually am not sure exactly if it's I don't think it's a point of time. I think it's actually an average. That's generally how NVIDIA SMI works.
Yeah, there's some sort of sampling happening for sure before it lands into Prometheus.
Could you talk about best practices for object store memory and best practices on cluster to avoid spilling? So I would just say one thing right now, which is that like you definitely want to make sure the object store is like sized appropriately. Oftentimes, like the default object store size may not be appropriate for it may be too small for data processing. And so in order to adjust that, you should definitely set object store memory when you start Ray. And you should configure it as high as possible to which your container allows. And in order to sort of have Ray be able to leverage the entire cluster memory effectively. HA available for ray train and no. So the answer is right now there's no the problem with like being able to do head node availability with some of the batch workloads is that like there's one driver script, and then if that driver script dies, like you'd have to figure out how to resume from that state of the driver script. And so like typically this is just a fundamental limitation of how programs are written. Um, and in order to sort of avoid the situation, we do recommend like making your like Ray Train does provide like checkpointing support, and so that's like something that you can definitely take advantage of when you're running training workloads. Matt Johnson asks, Ray is often advertised as supporting vast amount of data processing, but um, and I want to do feature engineering on a large data set like with Parquet or Avro. What do you recommend? I don't think Ray Dataset API supports join operations. That might be a choice. You might solve this problem with Spark or Dataflow. So the answer to this is that Ray datasets will be supporting joins in this upcoming quarter, but perhaps in like 1 or 2 weeks. The hash-based shuffle PR is already out, and that's like a very strong prerequisite for supporting joins. And so hopefully like Ray Data solves your problem in like 2 weeks. In the future, I mean, like if you want to do more, if you want like a large scale solution for data processing, like as you saw from Samsara, they would use something like Spark on Ray. Um, yeah, I think one thing that we would love is for you to give us feedback on Ray data sets and for us to sort of be able to meet your needs, especially for like feature engineering, this sort of uses. Dean asked, can I receive a copy of the slides? Yes, we will certainly be doing that.
Yeah, I just answered the question about being able to support SSO with the AD on any scale. I've just linked the documentation for you.
Okay, data log is Datadog. Okay,
Correct.
we'll
Thanks,
definitely fix that.
Wilson.
Yeah. What tracing tools do you see in production? Do you want to answer this one?
Yeah, right now, for most of the time, we are seeing like just open telemetry where folks would basically export the traces to open telemetry, and like that's sort of the de facto integration that we're seeing so far.
All right. Okay. I feel like we've been answering questions for 10 minutes, but somehow there's 37 more questions. All right. So we just answered tracing. Let's see. Any stats? I'm just gonna start. Okay, jump. So okay, I'll try to go order by order, and we'll probably have to finish up in
Yeah.
the next 2-3 minutes.
And I'll like type out the answers as much as I can so that will
Yeah.
be unblocked.
Yeah.
Richard.
Yeah, something that I find annoying in OSS Ray is that like the nodes die with the logs. It will die with, yeah. So we export to Datadog, but it's annoying to swap from Datadog to Ray dashboard. Unfortunately, I don't think there's any great way to do this aside from what you're doing right now. And hopefully in the future we'll have like a little bit better support for like a history server, but that's currently not being planned. Sorry, Brandon. Any stats or numbers for how much better RayTurbo performs in comparison to open source Ray? Depends on your use case, but as there's select sort of use cases that we can show that like RayTurbo will perform, like from 50% better to 5x better. But obviously depends on your workload. A lot of the work performance improvements will come from the Ray data. I want to learn deeper. I want to learn more about Ray clusters for inference, AnyScale Ray clusters for inference. So you can check out the AnyScale documentation and the AnyScale website, or reach out to Robin at AnyScale.com. So Robin at AnyScale.com can definitely hit you, help you out there. How much effort should I go into putting into arrow schema and arrow layout if it doesn't exist? We do recommend, I think for this sort of situation, if Arrow doesn't have great support for it and you can't find a custom extension for Arrow, probably best if you move to using Ray Core. Or, I mean, I guess like for Arrow, we will definitely do like the serialization. We'll automatically serialize to a Python object, which could work, but it may not be the best for use case. So Robin's answering the logging question. I'm gonna answer. So autoscaling is a powerful work feature for Ray Serve. What are some best practices for configuring autoscaling environments? in production environments. So unfortunately, I don't think we have time to answer this question, but this would be definitely great. Please stay tuned for like a separate webinar where we sort of talk about this. Great. Ben Reed asks, you mentioned explicit AWS, any skill support for AWS. Is there support for Azure? Right now, you just use like we do have AKS support, so we run any skill on top of the Kubernetes deployment on Azure, but that's like the main thing that we have. So it doesn't run directly on the Azure VMs, which is something that we have on the roadmap. And if you'd like to sort of accelerate that, you can talk to Robin as well. I'm gonna skip the meeting. We'll have materials related available. How does the Ray control plane integrate with the client managed control multi-cloud control plane? Please outline the interaction. Recommend you talking to Robin at Anyscale for this one. Why is a workflow orchestrator important in the production Ray stack? Good question. Basically, I think a lot of workflows may sort of rely on different stages, right? Like you might have like a variety of different Ray jobs, and it really depends on how you want to sort of orchestrate your how you want to sort of set up like the software engineering for your machine learning platform. Whether or not you want to have reusable components, in which case like the workflow orchestrator would be useful. And what I mean by reusable components, I mean by reusable scripts. For example, you have a data processing script that extracts like 5 features, another data processing script that extracts like another 5 features, and then you want to have like, the ability to reuse these components across different parts of your stack. It could be useful to use a workflow orchestrator. And then workflow orchestrator also provides checkpointing in between and job queuing and stuff like that. Does RayTurbo provide significant performance improvements for non ML power workloads such as data pipelines? Yes. So definitely that is true. We do sort of do a lot of data optimizations as well. All right. Yeah, I think we're basically at time, and it seems like we still have a lot of questions, and I think we will try to capture these in future webinars or answers later on. I think Eric has one last question that I'm interested in answering, which is like, will Ray support Daft, or will Ray datasets offer Daft's functionality? Daft does run on Ray, and depending on what you need, like Daft might be a better fit if you're looking at something that's like a little bit more like pandas. I think Daft is a good fit. If you're looking for something that's more for like scalable machine learning pipelines, like Ray datasets will provide that functionality over time. Okay, I think that's basically it. Unfortunately, I think we're out of time, and we hope this was super useful or useful to some extent, and we'll get those materials out to you very soon, along with the recording. I think that's basically it. Any last words?
Thanks a lot for joining.
Thanks. Bye-bye.